Welcome to Unstuck. Today's challenge, coin change. Given some coin values and a target amount, find the fewest coins that add up to it. We'll write the obvious recursive version, see why it's painfully slow, then rebuild it as dynamic programming that solves it in one clean pass. In Rust, typed out line by lines, every step explained. First, the problem. You're given coin values, say 1, 3, and 4, as many of each as you like, and a target amount, say 6. You want the fewest coins that add up to it. 6 is 3 plus 3, so the answer is 2. 4 plus 1 also makes 6. But that's 3 coins, so it loses. We want the minimum. Here's the idea behind the fast solution as a picture. We build a small table, DP, one slot per amount from 0 up to the target. Each slot holds the fewest coins to make that amount. DP of 0 is 0. Then for each amount we look back. If we use a coin, the cost is 1 plus whatever it took to make the remainder, which we've already solved. We fill left to right, and the last slot is our answer. Let's write it out, starting with the naive brute force way, so you feel the problem. What we define min coins as naive. If the amount is 0, we need 0 coins. That's our base case. Otherwise, we try every coin as the last coin we add. If it fits, we recurse to solve the smaller remaining amount, and if that was solvable, this path costs 1 more coin. We keep the smallest across all the coins. It is perfectly correct. But here is the trouble. To solve 6, it separately resolves 3 and 2 and 1 again and again in different branches, redoing the very same work, which makes it blow up exponentially. Now the fast version, dynamic programming, typed out line by line. The idea is to solve each amount once, and remember it. We make an array called DP, size 1 past the amount, where DP of A will hold the fewest coins to make A. We fill every slot with a big sentinel, meaning not reachable yet. The one thing we know for free is that DP of 0 equals 0. No coins make nothing. Then we build upward. For every amount from 1 to the target, we try each coin as the last coin added. If the coin fits and the remainder was reachable, then making this amount costs exactly 1 more coin than making the remainder, which we already computed. We keep the smallest option, and because we always go from smaller amounts to larger, every value we look back at is already final, never revisited. When the loop finishes, DP of the target is our answer, and if it is still the sentinel, the amount simply cannot be made from these coins. Finally, a small main that runs a handful of amounts through both the naive and the DP versions, so we can see they always agree. Let's run it. There it is, printed on screen. 2 makes 6, both the versions say 2 coins, 11 takes 3, that's 4 plus 4 plus 3, and the naive recursion and the DP agree on every case. The DP just gets there without recomputing the same amounts 1,000 times over. Side by side. The naive recursion resolves the same amounts in branch after branch, so it blows up exponentially. The DP solves each amount exactly once and reuses it, so it's the amount times the number of coins. With an array the size of the amount, same answer, but the difference between unusable and instant. That's the whole point of dynamic programming. Never solve the same sub-problem twice. Let's recap. Make an array where DP of A is the fewest coins to make. Start DP of 0 at 0, fill from 1 up to the target, and for each amount take the best coin. 1 plus DP of the remainder. The answer is DP of the target, and if it never got filled, the amount is impossible. Solve each sub-problem once, reuse it forever. A quick note, if these breakdowns help you level up, the wallet is on screen and there is a coffee link in the description. Every tip funds the next one. Thank you. Your turn. Comment the problem you want next and I'll build it just like this. If it helped, hit like and subscribe for more Rust. And remember the heart of dynamic programming: solve each subproblem once, then reuse it. Thanks for watching and I'll see you in the next one.